Okay, chapter 16.1, it's really just a review for the most part, especially if you took 308. So we're going to start by just solving linear equations. It's pretty simple, just one variable. So sometimes we like to draw the line to differentiate the two sides, and first thing we do is combine like terms on each side separately. So this gives us 27w. The minus 9 and plus 5, when those combine, that gives us a minus 4. Equals, this guy stays as is. We are going to combine these together, and that should give us a negative 4 also, or minus 4. Okay. And then, let's see what's next. Now it's time to isolate the variable to one side. Typically, I'll get rid of the smaller one, so I'm going to add 3w here. So I have to add 3w over here. So that cancels out, so now we've got 30w minus 4 equals negative 4. And then now that we got the variable on one side, we need to isolate it completely. So to isolate it, first you're going to add 4 here, so those two will cancel out. But then what I do to one side, I do to the other side. So now I have 30w. So the variable has been isolated, but not completely. To completely isolate it, we are going to have to go ahead and divide by 30. And 30 divided by 30, it's 1, but what it does is it cancels out towards 1w, or just w. And then 0 over 30, just 0. Okay? So really the rest of these are going to be more of the same. It's really not all that difficult. I probably won't work all of these, but let's go ahead and look at 13. So I'm going to distribute here. So I have to multiply both of these by negative 5. So negative 5x, and then this becomes minus 5 plus 3x plus 2 equals 6x plus 4. And then once again, we want to go ahead and combine like terms on each side, and you can draw that line down the middle if you want to not accidentally combine the 6x on this side. So you were just looking at the negative 5x and the plus 3x, which is negative 2x. Then we have minus 5 and plus 2. So when those combine together, that'll give us a minus 3. And then that equals 6x plus 4. Alright. And so now the negative 2x is smaller than the positive 6x, so I'll eliminate the negative 2x by adding 2x to both sides. Okay, you don't have to do it this way. I just always try to keep my variable positive, just to avoid making any mistakes later on. Alright, so let's see, that gives us 8x plus 4. And so I'm going to have to shrink this down a little bit, but hopefully you can kind of see where this is going. Let's see, go back to purple. Oop, that line didn't shift. Oh well, I think you'll have the idea here. So let's see, we'll subtract 4 on both sides, so negative 7 equals 8x. Divide by 8, divide by 8. That cancels out, so we're going to have x is equal to negative 7/8. Okay. So looking at these problems, it's really more the same. I'll just make a note here. You distribute the 3. This will become 6w plus 3. Then when you distribute here, you need to distribute the negative to both of these. So minus 2w, and then this becomes plus 4 equals 5. I really think y'all could pretty much take it at this point. You're going to combine these, combine right here. So I won't waste y'all's time working these out. I think you've already probably got a good grasp. So same thing here, just make sure, this will become minus 12, and this will become plus 8p. And so on, and don't forget about the 6p in front. But anyways, I'm going to skip a couple of these because, like I said, I don't want to waste y'all's time. I think y'all pretty much already know how to do those. But Let's look at 19 and 21. Okay, and you should have problems just like this in your homework. So here, you work the inside of the brackets first. So there's an understood -1 right here. So when you distribute this, it's going to change those signs. So the 2 is still here. And then we have w minus 2w minus 4 plus 3. Distribute the 2. 2w plus 2. And then before we distribute the 2 right here, you can do it now, but typically we want to go ahead and simplify inside before we distribute. So if you did, it would be okay, but it's better to just go ahead and combine this and get -w. And that should give us -1 equals 2w plus 2. And then now we'll go ahead and distribute the 2. -2w minus 2. Just doubled everything inside the brackets, that's all. Okay, and then once again you can kind of pick your own way of doing this, but I prefer to go ahead and add 2w to both sides. Okay, and so let's see, that cancels out, so we're left with -2 equals 4w plus 2. Our next step is going to be to subtract that 2 off to isolate the variable once again. So we get -4 equals 4w. Divide by 4. Divide by 4. That cancels out. So we've got -1 equals w. Okay. On 21... if you want, I don't really like dealing with fractions, and I'm sure y'all don't either. So what we're going to do is, and we've done this actually already in class, so this shouldn't really be anything new to you guys. A good idea is to get the LCD, which is 4, and then just go ahead and multiply both sides by 4, and it'll just make our life easier. So on the first one, when you distribute it, the 4 just cancels out, so I'm left with just 3x. On the second one, though, the 2 will reduce with the 4 down to a 2, so you're going to be left with 2 times 5, which is 10, and then we still have that x. So hopefully everybody's seeing what's happening here. Okay, if you want to, you could multiply it out. 4 times 3 is 12. 12 divided by 4 is 3. 4 times 5 is 20. Half of 20 is 10x. So hopefully you see that there. All right, 13 times 4, let's see, what is that, 52? All right, and so then we add this together, we get 13x equals 52. And then I believe when we divide 13 on both sides to figure out what x is, I believe we get 4. Okay, once again, not that bad. Like I said, we kind of already did stuff like that, so that shouldn't really be a shocker right there. All right, 25 is going to be basically the same deal. You're going to multiply by the LCD on each side. So I'll get 25 started, but I probably won't finish it. So if you're looking at 4 and 6, the LCD for those, I believe, is going to be 12. If you overestimate it, you'll actually be all right. If you accidentally overestimate it, but you're just making more work for yourself. All right, so we multiply both sides by 12. So I got to distribute it. So maybe I should actually show this just to make sure everybody follows, and then like I said, I'll probably won't work it any further than that. So I'm multiplying 12x by everything, so just so we can really get a good grasp of this. So then I'm going to have 12 times x plus 3 right here, divided by 6, and then on the other side, well, 3 times 12, that's 36. And so now the 4 will reduce to a 1 and the 12 to a 3. The 6 to a 1 and the 12 to a 2. So really there's no more fractions after this, so let me just rewrite this, and then I think I'm going to move to the next problem. So plus 2 times x plus 3 equals 36. And then, like I said, this is similar to problems we've already done. You distribute the 3, you distribute the 2, and solve for x. You really shouldn't have any problems. Okay, 27. Well, if you look in the book, they're going to show you how to manipulate the decimal places, and that's fine if you want to. You know, since you do have a calculator available to you, you can use that if you really want to. Either way is fine with me. But just let me kind of show you the idea behind this in case, you know, you did not have a calculator on you. If you notice, I need to shift these decimal places. Right now we're in the hundredths place. And I need to shift it 2 decimal places. So basically I'm going to multiply both sides by 100. So we multiply both sides by 100. Now you have to be careful when you distribute it. You only distribute it to these two on the left side, because the x plus 5,000 will eventually get trickled down, because this will eventually be distributed into this parentheses right here. So I know that confuses a lot of people, so be careful. So this is going to end up being 5x plus 12 times, see, nothing happened to these. Still just x plus 5,000. It's basically going to get trickled down in a minute, because see, that 0.12 turned into a 12, which is a big difference when that gets distributed in there. And then over here, this becomes, what is that, 94,000. Okay, and once again, I'll just stop here. I think y'all could take it from here. Not a big deal. Once again, if you want to, you could have just distributed the 0.12 and used the calculator. Not a big deal. Okay, so I'm going to try to wrap this up, because the recorder I'm using is only good for 15 minutes, and I'm almost at 12 minutes. So let me see if I can wrap up this first part of the notes, and that's going to be looking at the special cases of these. Okay, so what we're going to find out is sometimes when we look at these, the two sides look very different, but they might be equivalent. And then other times, there does not exist an x value that actually works for the expression. So let's go ahead and start working one of these. I'm kind of running low on time. So I'm going to distribute the 3 here, and at the same time I'll combine these like terms right here if you want to draw that line again. So let's see, that should give me 3x because negative x, and then we got the minus 9 equals, then when I distribute, I get 3x minus 12 minus 5. Now this is what I'm talking about right here. You notice we've got 3x and 3x on both sides. Those guys are going to cancel each other out. You know, you could basically subtract 3x from both sides, so you can just cancel them out if you want. So we're left with negative 9 equals, and then if we look here, we've got negative 12 and minus 5, which is going to give us negative 17, which is false. That's not true. It's false. So that one's going to have no solution. Okay? That means that there's no x value that you can plug in that makes the two sides equal, because see, the 3x's, whatever you plug in, those kind of offset each other. So you're always going to have a false statement, so nothing's going to work there. Alright, let's look at 35. Let's see if this one's any different. So we distribute here, so we've got negative 11x plus 4x minus 12 plus 6x equals 4x minus 12. Alright, so let's go ahead and simplify. Let's get our like terms on the left side together. So 11x plus 4x plus 6x. Let's see, that'll give us negative x minus 12. This one looks like we might actually have an answer here. So let's see. Once again, you know, if something appears on both sides, they're basically going to cancel out. So the 12s basically cancel out. I mean, I don't have to do that now, but you can. If you kind of get good at those steps, you can kind of just do that. And hopefully you know what x is at this point. Okay, because negative x plus x is 0. This gives you 5 times x. So basically, what times x gives you 0? Well, hopefully that's pretty obvious. It's just x equals 0. Okay, I have only got 30 seconds, so this is going to be tough to do, but I'm going to try to do this. So we distribute here, and I think what's going to happen is at the end of this problem, you're going to end up with a true statement. And if it's true, that means that you're going to have infinitely many solutions. So let's see. Right here, this connects to give us negative 3t minus 10. Then over here you got negative 3t. When you connect these, you